Hello, here is lesson 22 of the daily math entry activity. Your target, of course, is to attempt each and every problem. You should at least attempt every problem, then check your work. So if you haven't already tried every problem, go back and try them, then watch the video and fix everything. So number one, Uriel and Christian each bought a whole pizza. Uriel ate 5/10 of his pizza. Christian ate 3/5 of his pizza. Which person ate more, Uriel or Christian? Okay, so Uriel's pizza, 5/10. The 5/10, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and he's got 5 of them. So he ate 5/10, right? So that's pretty easy to see that 5/10, it's half, right? Now the other one, 3/5, is harder to see because these aren't tenths. They're not fifths, they are tenths, sorry. But if I break these into bigger pieces, that is not at all working. What is wrong here? If I break these into double pieces, now I've got fifths. So 2/10 is the same as a fifth. So here we've got over here this 3/5 is the same as 6/10. So number one, Uriel and Christian each bought a whole pizza. Uriel ate 5/10 of his pizza. Christian ate 3/5 of his pizza. Which person ate more, Uriel or Christian? And the drawing, you don't really know. Is the shaded part what they ate, or is the shaded part what's left? So we can't just look at the picture and know for sure. So Uriel ate 5/10. This one is Uriel. So tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 of them, and he ate 5/10. So that's pretty easy. 1, 2, 3, 4, 5/10. So 5/10. 5/10. And then 3/5. How much is 3/5? Well, the way to do 3/5 is to make this be fifths instead of tenths. And if I break it like this, now I have 1, 2, 3, 4, 5 pieces, and he ate 3 of those 5. So he ate, it is the shaded part that is what they ate. There's 3/5. So this is 3/5, which we can see is 1, 2, 3, 4, 5, 6/10. So who ate more? It turns out that 3/5 is more than 5/10. So I guess it's Christian who ate 3/5. Christian ate more. And 3/5 is more than 5/10. Okay, number 2, complete the matching table for each statement. 9,500 is 10 times smaller than 95,000. So if 9,500 is 10 times smaller than 95,000, that means 95,000 is 10 times greater than 9,500. So basically we are saying 9,500. If we multiply that by 10, is it 95,000? Is that true? Well, we know that if we multiply by 10, we should have one more zero in our product, and we do have one more zero in our product with 95,000, so this one is true. 5 thousands plus 9 tens is 10 times larger than 509. Okay, 5,000 plus 9 tens would be 5,090. And is that 10 times more than 509? So if we did 509 times 10, remember if we times by 10, we would just place an extra zero. It looks like these are the same thing. So I'm going to say this one is also true. 59 is 100 times smaller than 59,000. Or 59,000 is 100 times greater than 59. So is 59 times 100, what is that? We'd get 59. We'd place these two zeros. 5,900, that is false. It is not 59,000, it's only 5,900. Number 3, when rounding to the nearest thousand, what is the greatest whole number that rounds to 23,000? So I'm going to do a place value chart here. So here's, oh, I want that to be blue. Here's 23,000. Here's the thousands place. And we want to know what's the greatest number? How high can I go and still have it round down to 23,000? Well, here's what I know is that if I'm rounding to the nearest thousand, I look at the hundreds place, and I know that if I get to 5, I'm more than halfway there, and 5 would round up, and I have to round back down. So this is going to have to be a 4 to round back down. Because I know in the place next door, 4 would bring me back to 23,000. 5 would round up to 24,000. So I'm going to keep the 3 and the 2. And then can I go any higher than these and still have it round down? Yeah, I can. I can go to 499. That is the greatest number I can go and still have it round down to 23,000. Because if I went to 23,500, that 5 would tell me to round up, and it would be 24,000. It would not round to 23,000. So 23,499 is the greatest number that still rounds back down to 23,000 if we're rounding to the nearest thousand. So 23,499, that's as high as I can go. Number 4, complete the list of the first 6 multiples of 100. Multiples means multiply, okay? And they're multiples of 100, so we're multiplying by 100. So the multiples of 100, 1 times 100 is 100. 2 times 100, that's the second multiple. 200s would be 200. 3 times 100 would be 300. 4 times 100 would be 400. So the first, second, third, fourth, the 5th multiple of 100 is 500, and the 6th multiple of 100 is 600. Number 5, Zach and his band travel a total of 5 miles between each show. How many shows will they play over a span of 60 miles? So I made a diagram. They said 5 miles between each show. So here's my first show. They go 5 miles between the first and the second. So they keep going 5s. So I kind of need to just count this up. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So it looks like they are to the 13th show by the time that they have gone 60 miles. Because here, I'll write this again for you. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Now, they did say 5 miles between each show. There is another way that you could have looked at this. You could have said that they started at show 0, like they started at home, and went 5 miles till they got to show 1. So this is a problem that's really not well written. Because if we said that it was, if they weren't starting at show 1, if they were starting at no shows and show 1 was here, then it's 12 shows till they get to 60 miles. So if you got 13 shows or 12 shows, then I would say that you got it correct. Some people may have said 60 divided by 5 equals 12 and gotten to 12 shows. So we're going to say 12 or 13 shows, depending on how you think about it. Okay, you should have changed your answers and also written down the work we did here. Okay, so you should have all of this stuff written down, this stuff written down. Everything I wrote, you should write too. All right, thank you. Bye.